Hello and welcome to this lesson on margins, padding, and gravity in Android UI design. In this lesson, we'll cover the spacing techniques used to achieve desired placements of UI components. Margins and padding can be utilized to create proper spacing between view elements, and inside that element between the borders of the element and the content. This is sometimes referred to as the box model. This diagram illustrates how these constraints can be defined to correctly design our UI. Margins and padding in Android can be defined in pixels, points, inches, millimeters, or density-independent pixels. The most common unit of measurement for margins and padding is DIP, or density-independent pixels, because this allows for definitions to be more effectively scaled and adaptively fit screens at different sizes and screen densities. Let's start off with the green square, the view on which we are declaring margins and padding. The gray area around the green view represents the spacing between our view and other UI components, which might also constitute the edges of our parent view. We can define a margin left here to declare that a view should have that much room between the left view or parent edge and itself. In similar fashions, we can define the margin top, margin right, or margin bottom. We can also declare the margin attribute to a value to preset the left, top, right, and bottom margins all to the same value. The blue rectangle in the middle of our view is the content of our view. For instance, in the case of a text field, this would be the actual text within our view. In order to define its location within our view, we use the padding properties. For instance, if we define the padding top to be 20 DIP, then our content will be a span of 20 DIP from the top of the view. In a similar fashion, we can declare padding left or padding right to adjust our content's distance from the left and right edges of our view. When designing views for Android, the gravity attribute is an attribute that allows us to define an object's placement inside of its parent view in a more general fashion than margins. This attribute is commonly used as the layout gravity attribute of a child that has a parent view of a linear layout. Some of the types of gravity that can be set to a view include bottom, which would push an object to the bottom of its parent container, center, which would place the object in the center of its parent container in both the vertical and horizontal axis, center horizontal, which would place an object in the horizontal center of its parent container, center vertical, which would place an object in the vertical center of its parent container, end, which would push an object to the x-axis position at the end of its parent container, fill, which would grow the horizontal and vertical size of an object if needed so it completely fills its parent container, left, which would push an object to the left of its parent container, right, which would push an object to the right of its parent container, top, which would push an object to the top of its parent container, and much, much more. Now let's take a look at how to define margins, padding, and gravity in the XML for our UI. We have designed 3 XMLs for this demo application: activity main gravity, activity main margins, and activity main padding. First, let's take a look at our Dimens XML file in our values folder. The Dimens XML file is a convenient location to store our more common values or dimensions for things like margins or padding. Here we have declared 2 margin sizes, margin big and margin small, and 2 padding sizes, padding big and padding small. Note that we are using the DP unit, or density independent pixel unit, which we previously referred to as DIP. We can easily declare these values throughout our application. If the need arises to change these definitions, we simply need to change them in our dimens.xml file, and we'll apply these changes to any reference of these constants in our whole application. In addition, we can declare different values for this dimension constants for different screen sizes, resolutions, versions of Android, and other configurations when needed by using the naming conventions we discussed previously. Now let's jump into our activity main margins file. We see in our activity main margins XML we have 3 text views nested inside of a relative layout. We notice that there are already predefined paddings for the relative layout. This was generated when we created our project and created this layout. If we take a look at the first text view, we see that it has a top margin of 16 dp. This value is taken from our dimensions definitions for margin small. Then we have a second text view to the right of our first, with a margin top and left of margin big value. And finally a third text view to the right of the second, with a margin top and left of margin small. If we take a look in our design view, we can see that the margins affect the text view placement, so that each one is placed according to the margins that we predefined. Now let's take a look at our activity main padding file. For this padding example, we utilized a linear layout with the same predefined padding attributes as our previous relative layout. The vertical linear layout will place one child after another in the order that they are listed. So that we can more easily see the padding within elements, we give each text view a background color by defining the background attribute. Here we're using a resource from the Android system, denoted by the @Android prefix. In this case, we're using a color of hollow green light. In the first text view, we use padding left and top of padding small, and padding right and bottom of padding big. In the second text view, our padding top is padding small, while all the other paddings are padding big. We also give it a background of Android system color hollow orange dark. And in the file text view, we have no padding at all. If we switch to our design view again, we can see how the text placement differs in each view based on the declared padding. Now let's open our activity main gravity file and see how gravity can affect views. In our activity main gravity XML layout file, we have our same three text views with a linear layout, but this time we assign each text view a different layout gravity, from left to center to right. When we take a look in our design view, we see that they are placed accordingly inside of the vertical layout. As you may have noticed, in this example, we have three separate layouts to demo for this application, and only one activity, our main activity. So let's open that now. In order to run each one of these layouts, we simply need to change which layout is set during the setContentView call in our onCreate method. Here we have commented out the padding and gravity layouts, so they will not be shown. And instead we'll show our margins layout. In order to run the application using the padding layout, for example, we simply need to comment out the setContentView for our margins. We can use the shortcut here of Control and slash, and then comment back in the setContentView for our padding. Again, we can use a shortcut or simply delete the comment slashes. This can be done using the shortcuts or using simple edit and copy. And then once we run our application on a device or emulator, we'll see the layout which we have set in our content view. Thank you for joining us in this lesson on margins, padding, and gravity in Android views. Join us in our next lesson where we'll cover the lab exercise for this section.